So for this assignment, we are going to work through some velocity and momentum word problems. They're going to start pretty simple, and then there's going to be a couple more that are a little more advanced, but nothing that we can't handle. So velocity is something that we've been working on for a couple weeks now, looking at it at all different ways. So these are going to be a little bit of review. Momentum is a new concept, so we've read about it, you've done a practice lab, you've heard about how collisions work in terms of conservation of momentum. So today we're going to do some calculations. It's a new calculation, but it is pretty simple. So there are 9 problems. We're going to do 4 of these together and then also go over the equation and what velocity and momentum are looking at. So let's pull in to this one. Okay. So let's look at our equations to start off. We are starting off with our velocity equation. So hopefully you remember this one is B equals D over T. Or velocity slash speed is equal to distance divided by time, a distance over time. So velocity or speed is a rate. Any of those are going to be a measurement done over time. Time is always in the denominator when we're making our measurements or doing our equations. For momentum, this is a new equation that you've read about, but we are going to calculate now. So momentum is abbreviated as a lowercase p, and the reason for that is, as we've talked about, literally just the m's were taken up for momentum. So m already stood for mass, it stands for meter, it stands for molarity or the number of moles, so they'd run out of things to use. So it comes from the term Principia Mathematica, which is a writing done by Isaac Newton where he first described the idea of momentum. So they named it after that, Principia, as a P, because nothing else was P yet. So momentum, our lowercase p, is equal to our mass times velocity. So this is something that we saw in our lab, that as we increase our mass, our momentum went up, or when we increase the speed, the momentum of the object goes up. So luckily for us, as we do our calculations, it is in a 1-to-1 ratio. You don't have to do 2m times v. It's just literally a 1-to-1 ratio of your mass and your velocity. So let's try these out. I'm going to go through some problems and then leave you the ones that are kind of replicas of the ones that we do together. So we'll go through each problem type and see how we do. So I'm just going to show you how I solve these problems. So we have for number 1, a 2 kilogram ball has a momentum of 25 kilogram meters per second, is how we read that unit. What is the ball's speed? So the first thing I do, just as habit when I'm doing a word problem, even if I already know how to do it, is that I highlight or I circle all of the information that they've given me. So I'm just going to highlight that. And then the last thing that I always do, and I've put for you here to do, is that I show what the question is. What am I looking for? So some of these word problems, these ones are pretty straightforward, but sometimes in physics we have a whole bunch of information, and it's nice to just have like a focus point to remind us that we are only looking for one thing, and then we can kind of work backwards from there. And that will become more clear why we do that as we move forward with our work. So my known values, I'm going to fill these in now with what those actually are. So now that I've looked at all the data they've given me, all the numbers, I'm going to label them with what type of measurement it is. So I know I have a 2 kilogram ball, and I know that kilograms stands for mass, or is the unit for mass. So I'm going to just label that as the mass, and then has a momentum of 25 kilogram meters per second. So this is a new unit for us to use, but they tell us that is the momentum, so I'm going to label that with a P. And what I need to find is my speed or velocity. So I use V even when they ask for speed, because the numeric part of it, the part that I would actually calculate, is the same whether it's a speed or velocity. I just use the velocity equation all the time. It's one less thing to keep track of, one less variable to keep track of, so I just say V there. So now that we have them, this is where these problems can get a little tricky if you're stressed out while you're thinking about it, is that they ask for the speed / velocity, but if we look at our speed and velocity equation up here, we don't have the right variables to solve that. So when we're asking for velocity, they're asking for the distance and the time, and those are not the variables that we've been given. We've been giving momentum and mass. So what you want to do is, and why I like to really make clear which variables I have, what type of measurements I have already, is that when I've collected these abbreviations, I have an M, P, and V. I'm going to go back and look at my equation list and see what equation that fits into. Is there, like, what possible information could I use here? So if I do that, I can see that it fits my momentum equation. That even though I'm looking for my V, my velocity, because I have the momentum and the mass already, it's going to be useful for us there. So we are going to use the momentum equation to solve for speed. So now I'm just going to plug my numbers in. First, I'm going to copy. I always like to start off by copying my equation in with just the variables, because it helps me to make sure I plug everything in the right spot. Again, it's easy right now when we're only dealing with 3 things, 2 different numbers and a variable, but it can get complicated later on, so just for best practices, I like to keep it there. So I'm going to plug in 25 kilogram meters per second, and that is equal to my mass of 2 kilograms times my velocity. Okay, and now to solve this, the rest I'm going to solve in black. I'm going to stop color coding as we combine numbers. What I'm going to do is to isolate V, isolate my speed or velocity, so I'm going to divide by 2 kilograms. And this is just our basic algebra. If you do something on one side, you do it to the other to keep it balanced. And over here, 2 kilograms crosses out, cancels out. And over here, our unit of kilograms cancels out. And then we're left with 25 divided by 2 and meters per second. So 25 divided by 2, 25, I don't know why I wrote that again. We can just bring that down. 25 divided by 2 is 12.5. And the unit that we have is meters per second, equals V. So to double check this, what I like to do is, because I've kept my units in the whole time, it's kind of a nice fail-safe to make sure that I've done my math correctly. So if I do my math correctly, once I've canceled out the units that do cancel while I do it, so this kilogram here canceled out because it was on the numerator and denominator, I'm left with meters per second. So then I double check, is meters per second the right unit for what I'm looking for? So meters per second is the correct unit for velocity. So it's just kind of a nice check to see if I did it right. So for example, if I had canceled this out incorrectly, if I had accidentally done, let's put it in red to show that I did it wrong. Or let's use a new color, I guess. I'll put it light here. So if I'd done times 2 kilograms and then times 2 kilograms, I'm going to keep it kind of like a ghost because it's the wrong answer, and then I'd thought that canceled out, I wouldn't have been able to cancel out the kilograms over here, so I can't like check that I've done it right. So because it worked, I'm going to assume I did the rest right. I'm going to box in my answer. However you like to show that you have the right answer, do that. So I have 12.5 meters per second equals velocity. Okay, so number 2, I am not actually going to do because it's the same thing, it's just different numbers, so I think you can go through and solve that one yourself, try it yourself. I am going to do number 3 because it is just it's a pretty straightforward momentum problem. So I want to do one of those. Okay, so we are going to start with our highlighting, and we are going to see what we know. Let me just pull this down. So as we highlight, we have a 1.5 kilogram ball thrown at 10 meters per second, and we want to know its momentum. So I have 1.5 kilograms thrown at 10 meters per second. I'm looking for the momentum. And we're just going to label those things again. So we're trying to find P, momentum. Here, none of these are labeled with what they are, so we have to use our context clues and our knowledge of our units. So 1.5 kilograms. Generally, when something is just described with like when an object is described, usually the measurement is its mass. Sometimes it's volume, but for these, they're going to be mass. So we double check, kilogram is our mass unit, so we're going to say this is M. And then it's thrown at 10 meters per second. So meters per second is our velocity unit, but also if there wasn't a unit there, or if you didn't recognize the unit, how we would describe a throw, how we describe an action, is generally its speed. So we end up with M, V, and P, which fit right into P equals mv. We have all 3 parts, so we are going to plug those into the equation. I'll color code this again, just for this one. So we end up with P equals, and I'm going to put my mass in, 1.5 kilograms times 10 meters per second. So we're left with 1.5 kilograms times 10, and when you're multiplying by 10, what we can do is, because there's 1 0 there, we are going to move our decimal spot over 1 time, and we get 15 kilogram meters per second. And that is our unit. That's it. Momentum, when we're looking for momentum, is probably the easiest measurement to find. It's just one straight multiplication problem. There's no new unit to use. The kilogram meters per second is literally just saying 1 kilogram moving at 1 meters per second. Like, how many of those do you have combined? So you don't have to remember anything fancy there. Numbers 4 and 5 I am not going to do. So let me zoom out for a second so you can see this. Because this is very similar to numbers 1 and 2. So this time you're given the speed and momentum of an object and looking for the mass, which you're going to find in the same way that you would find the speed if you had the mass, because they're interchangeable in that equation. So let's look over here. This is the back side or the second page of that worksheet. We have the same thing, that we are looking for a mass and you're given a speed and momentum. So I think you can figure those ones out. I am going to do number 6. We're going to try together. Because this is just slightly more complicated and I want you to see that it's not actually so bad. It just looks a little bit worse. Okay, so we have your brother's mass is 40 kilograms and he has a 1.3 kilogram skateboard. What is the combined momentum of your brother and his skateboard if they are going 8.5 meters per second? So, the only thing that is harder here is that there are extra measurements. So let's just go through how we can do these. So we have a 40 kilogram, a 1.3 kilogram. I'm going to highlight those the same color because it's the same unit. They are going 8.5 meters per second. And then the question is here, what is the combined momentum? So we are going to label this. What is the combined momentum? So we are looking for a P. We want a momentum. And then at the beginning it says your brother's mass is 40 kilograms, so let's call that a mass, and I have to write it over the problem. And then here, his skateboard is also in kilograms, so that's also going to be a mass. And in green, our 8.5 meters per second, if he is going, that's going to be a speed or velocity. So I'll label that here. So again, we have a M, V, and a P, so this is going to use our P equals M, V equation. So now we have two options. The only difference here is it asks for the combined momentum instead of just asking for the momentum of one object. Now you have a person and a skateboard. There's two ways that we can solve this, and I'm going to do both to show you that they do give you the same answer. You can use whichever one you would like. I'll leave that up to you. I was going to say one is easier, but it might be easier for you and it might not. So what we're going to do is, I guess our two options, they are both traveling at the same velocity. This is the only reason it's going to work so easily here, is I can expand this equation as saying the total or the combined momentum is equal to the combined masses. So I'm going to call them M1, mass 1, and mass 2. So combine them, we just add them together, times the velocity. So mass 1 and mass 2 are in parentheses and then multiplied by the velocity because they're both moving at the same speed. If we were trying to find the combined momentum of two things traveling at two velocities, we'll try that later on. We're going to have to do more work. But here we can combine the masses right here. Let's take that out now that I've said it. Okay, so let's try and plug this in. We are going to color code again since there's so many numbers this time. So we get P equals 40 kilograms plus 1.3 kilograms times 8.5. So then we have P equals 41.3 kilograms times 8.5, and now it just looks like a straight momentum problem. And the answer to this, I am going to do off camera on a calculator because I can't do that one in my head. So we have 41.3 times 8.5 equals, put it in black, P equals 351 8.05 kilogram meters per second. So I'm not going to box it in yet because I'm going to try it the second way that's an option and double check that we get the same answer. So the other way that we can do this is if we go back to the beginning, I can say I want to find the combined momentum, so I'm going to find the momentum of the skateboard, I'm going to find the momentum of my brother, and then I'm going to add them together. So we could also say P1 plus P2 equals P combined. Hopefully that makes sense. So let's find actually the mass of the brother first, since his measurement came up first. So we will say, and I'm actually going to do this quickly. I'm not going to put the units, I'm not going to color code because we already figured that out on one side. This is just to double check that we did it right. So I'm going to say, for my brother, actually let's say that first, bro, let me just say bro here, is going to be P equals MB, P equals 40 times 8.5, and then P equals, and we'll do this off camera too, 40 times 8.5 equals 340. And since I'm just double checking that the numbers turn out, I'm not worried about units here. So then the skateboard, I'll say SB here, still the same, P equals MV, P equals 1.3 times 8.5, and then P equals 11.05. And I know this because I calculated it earlier. So then I'm going to say if it's P1 plus P2, we get 340 plus 11.05 equals 351.05. So we'll double check. We get the same number on both sides. So either one will work. Now that I know it's right, I'm going to box in my answer with the unit. We always want our units so our numbers make sense. And then this over here was just the fact check. So it doesn't matter which way you do it. As we can see, they both give the right answer as long as they both have the units. Whichever one you prefer, do it that way. I think the first way is faster, but it doesn't matter. Okay, so I'm going to leave number 7 to you because it's the same thing, except everything's a little bit heavier this time. So I want you to try it. You don't have to do both ways like I did. Just choose whichever way you think is easiest. And then we have 2 easier questions. So the only difference here is we want to double check if you are given a direction. I'm going to highlight these. If you're given a direction and then you're asked for a momentum, you want to include that direction in your answer. So that's the only trick for this last one here, is that numbers 1 through 5 did not have a direction attached to them. Now that I have one, I should use it. And then number 8 is just a review speed or velocity problem. So I think you should be able to do that. This is the only one, I'm going to give you this hint, this is the only one where you are going to use the equation V equals d over t. So the only time that we're using distance and time to find our speed instead of figuring it out from momentum. So I hope this helped a little bit to walk through the problems. Momentum is a pretty straightforward thing to calculate. It does get used for more complicated things later. So we're going to ease into it. We've talked about collisions, and now we're going to talk about the equations for just plain momentum, and then we're going to try and talk about the equations for collisions. And that's where it gets a little bit tricky, but I think the most interesting part, that if we know the mass and velocity of one object, and then we know like the mass of the object it's going to hit, we can see how fast that new object is going to go, or something like that. That might just be more confusing right now. The point is that these equations, these problems we're going to do, you can use to find out some really interesting things that I think it's interesting you maybe didn't know that you could calculate this or know or predict what's going to happen. So I want you to try these. Do your best. If you don't understand them, try as much as you can and then bring them to class, and we'll go over them again in class.